All right, so the last step is to just put it all together. So I have 6 IR spectra, I have 6 compounds up top, and we're going to try to match all of these. I do have this posted on Canvas, so if you want to pause the video, try to figure it out yourself, and then review the video to make sure you got it right, that would probably be a good idea. But we're going to take a look at the spectra and see what they can tell us, right? So here we have this spectra right here. And we want to think about what it tells us, right? Here's 1500, so this line is 16, 17. So we've got a very strong peak around 1700. That's most likely going to be a carbonyl peak, right? This right here, those are our CHs, right? Just our regular alkyl CHs. So this tells us that's probably going to be a pretty boring molecule, right? We don't see any triple bonds. We don't see any alkyls beyond 3000, so we don't see any carbon-carbon double bonds. We don't see any alcohols. So this one is probably just some kind of plain carbonyl. If we go over to this next one, probably the first thing that you observe is this very broad peak, right? Remember, that's an alcohol peak. So let me kind of color code this. OH peak, right? That's something that you should observe. Maybe another thing that you observe is this peak right here. It's beyond 3000, right? That little side peak. That's probably some kind of carbon hydrogen where the carbon is a double bond. And as well, you can see some peaks over here that are weak that probably indicate some kind of carbon-carbon double bond, right? So this is what this spectra tells us. Again, this tells us CH bonds, but that's not really that useful. This is all fingerprint region, so we don't even look here. Next up, right, you've got some kind of, fingerprint region, some random stuff here. You've got this broad peak over here. You're not quite really sure what that tells us. If we look over here, right, we see CH bonds, but again, not really that useful. And then we see this broad peak with this double thing. And so we can tell that's probably a nitrogen with 2 hydrogens attached to it. Probably should have switched colors here. Let me switch this to blue. Let's switch that to green. Okay, switch that to green. All right, so next up, we're at this IR spectra right here. Right here's the 1500 line, so we just ignore all of that, and we don't see anything here, right? So no double bonds, no nothing cool like that. We don't see anything past 3000, so no alcohols, no sp2 carbon hydrogen bonds. This just tells us regular carbon hydrogen bonds. So this molecule overall looks quite boring, but let's continue on. Next up, we're at this guy again. We ignore the whole fingerprint region, right? This is 1500, this is 16, this is 1700. So we see this carbonyl peak right here. And then we also see this big old alcohol peak here, right? And notice that both the carbonyl and the alcohol peak are very broad. And so that should indicate to you that this is most likely going to be some kind of carboxylic acid. And then over here, we've got this compound here. I guess we'll do this kind of weird yellow thing. Ignore this whole side over here. We're above 2000, about 2200, something like that. That's right in that triple bond region. So we've probably got some kind of carbon triply bound to something, right? These are just your regular carbon hydrogen bonds. And so then we see the sharp peak a good bit above 3000. That probably indicates a triple bond carbon with a hydrogen, right? And so now that we've analyzed all of these spectra, we can go ahead and try to match them. And so you can start wherever, right? This is the only one that indicated a triple bond. And so let's take a look at our molecules. If we take a look at our molecules, there's only one of them with a triple bond. So that's got to match up with that one. Maybe another cool one you pick over here is this nitrogen with 2 hydrogens on it. Can we find something that just fits that detail? Yep, it's got that one right there. So we're good there. The next one I would pick is maybe this pink one, right? A carboxylic acid. That's pretty unique. If we take a look at our compounds, this is the only one that has a carboxylic acid. So we're good to go there. And then if we look at our remaining compounds, right, only one of them has a carbonyl, and that was one of our signature peaks. And so if we think about which ones that are left that have a carbonyl, there's this orange one, and so that peak's got to correspond to there. And then here we have this alcohol and this double bond, which we identified right there. And so that one's got to go with this one. And then finally, this boring one over here has nothing in terms of the IR, right? We can't see carbon-nitrogen bonds, so we can't really see that through the IR. And all we see is the alkyl groups. And so you can see how IR helps you predict the functional groups of compounds. Another useful thing about IR is that it's a very quick and easy method to do depending on your setup. Some setups are a little quicker than others. But if you get like a good one, it takes maybe like a minute to do an IR. And so if you're running a reaction, it's quite useful, right? So for example, let's say maybe you have an alkyne and you're going to react it with some sulfuric acid, some water, and some mercury sulfate to form your ketone here. You can think about how can the IR tell me if my reaction proceeded or not, right? Well, we can think about we have a carbon-carbon triple bond, and so we should be able to expect that peak in our reagents. And then if our reaction is progressing right around 1700, we should have a very strong peak, right? So by knowing how to read an IR, you can tell how your reaction is progressing.